Hello, this is presentation for paper predicting plant water and soil nutrient requirements. So what are we talking about here? We're talking about a tool that is intended for farmers which are dealing with crops. This tool should provide them with predictions and pieces of advice considering their goal of producing certain cultures in, for example, following season, based on the information that they provide this tool to. So basically, it is a why are we doing this? This is done since there is a big lack of education and information within this industry, considering those practices. So people dealing with these type of businesses are generally easily affected by nature and unpredicted events. So our goal is to make their businesses more stable and predictable. So when taken wrong actions, there are short-term and long-term goals which can be financial and material in the sense of materials needed for production. So first of all, short-term goals are, in this paper, we are talking about corn, sunflower, and wheat. So I'll be using those examples. For example, we want to produce in the next season corn, but we were producing sunflower for past 5 years. We adapted our soil and our practices to sunflower. And we need to change them in order to successfully cultivate corn and to have a wide production as we want and as quality of the product as we want. So the short-term negative consequences are those of, first of all, failing the first season when we take wrong actions. So for example, we didn't fertilize our soil as we should have, or we didn't plant our plants enough. So in the first season, our investment fails. We do not have enough resources for the following season, and we made damage to the soil. So in the following seasons, we need to, first of all, rejuvenate our soil and make it adapted to the culture that we want to cultivate. And if those actions are not taken, then we have even longer consequences due to not treating the soil properly. So the overall quality of our business decreases. This tool is easy to use since people who are in these businesses do not have enough time to learn or dedicate so much education and training for certain things. So we are giving them the final product where they just enter some data that is needed and they have the prediction. So this is a part of Uniform Solution. I'll just run through this. This is a part of a larger web platform that is intended for all the stakeholders of the agricultural industry. This concrete tool is of course, intended only for farmers, so not distributors, etc. So generally, agriculture is a very large economic branch. It is very underdeveloped. The need for digitalization is large. It's huge due to the underdeveloped governance and hard time putting products on the market for the farmers. And as well, it is very important to say that our day-to-day life has been moved to kind of digital platforms, whether that is our smartphone or laptop. Our way of informing and educating ourselves and spending our time is kind of moved to that. And also a lot of businesses have been moved to some form of digital business. So we think that in this culture, in this branch, this is very needed as well. So this is how we are trying to contribute. So also it is important to say that EU has in the past period a very dedicated policies and requirements for the countries within the EU, but also to the countries that are in the process of integration. So there are many financial support and initiatives in order to help this branch thrive. Methodologies used in this paper are now going to be discussed. So we have 2 experiments done. So it is predictions made for plant watering and for fertilization of soil. So first we're talking about plant watering. Data that is used in making these predictions is hourly collected for every day for 13 years, so from 2005 to 2018. First it is evapotranspiration is calculated, then we choose the culture that we want to cultivate, so in this example sunflower, wheat or corn, and every culture has its own coefficient. So that coefficient is multiplied with the evapotranspiration that we already obtained, and we have the evapotranspiration for the concrete culture that we want to cultivate. So evapotranspiration is estimated daily. Method used is FAO Panamon Montate, and it is based on meteorological data gathered by the weather station. Weather station is airport weather station at Vršac, and the data is gathered from air temperature at 2 meters above the ground, dew point 2 meters above the ground, wind speed at 10 meters above the ground, atmospheric pressure at 2 meters above the ground every day of the year, and the geographical latitude is also counted in. So let's talk about it concretely. So it is important to say that temperature of the soil was not considered, but it is important to say that since we obtained meteorological data, agrometeorological data from measurements at 2 meters above the ground, in order to compensate and adjust for the height difference between the measured and standard values, for example, we needed to multiply wind speed by 0.75. Limits of this method, of this methodology, is that solar radiation was not measured, but instead for estimation are used relative sunshine duration, was used a relative sunshine duration based on the geographical latitude and date, as we said, every day during the course of 13 years. So evapotranspiration is also possible to be overestimated since we have limited data availability. We calculated, or we assumed number of bright sunshine hours taken from sunrise to sunset, even though maybe not every day has that number of bright sunshine hours. This is the following equation used for evapotranspiration calculation. It is important to say that the result of this equation is given in Kelvin scale for temperature, and we need for Celsius. So the given result is needed to, we are adding that result by 273 in order to obtain Celsius value. So now we are talking about adding different soil macronutrients. So this is another methodology. So first we need to say that we have limited data availability considering soil analysis. We used the NPK method, which is nitrogen, phosphorus, potassium. So nitrogen is expressed as percentage of soil content. Phosphorus is expressed as milligrams of this given chemical compound in 100 grams of soil, as well as potassium, but in this given chemical compound. AgroZavod recommendations are used, so annual soil targets were set for nutrient content based on the crop that is going to be calculated with pre-targeted yields. So basically what we are doing here is that we are developing a tool where you, as a user, decide on how much of the product you want to have in tons per hectare, and you obtain and you give the data to the application, to the tool that you have regarding your soil. So for this concrete season at this moment, the calculations then come to the stage, and we have the prediction. So for example, we say we have this this is MPK, so 320 is value for nitrogen, 80 is value for phosphorus, and 72 is value for potassium for 9 tons per hectare of corn grain, and so for sunflower, and so for wheat. So the system takes an input, as I already said, of a point of origin in terms of soil fertility and a claim of the plant crop cultivation. So the system will then advise the farmer on the amount of fertilizers that needs to be introduced into the soil in order to support such production. So we first of all adapt our soil for the culture that we need to that we want to cultivate in the following season. So we have a better quality product, we have immediate results when these actions are taken, and we do not have that gap between seasons or one season or whatever. It depends on the damage that is done, so we have the immediate right actions taken with this concrete piece of advice. So limits of this method is that it does not subdivide the fertilization practices into periods, but only the yearly nutrient balance. So this is the calculation made for fertilizers, so for nitrogen, phosphorus, and potassium. These are the formulas, and the resulting values are expressed as kilograms of fertilizers per hectare of land over the year. Now we are going to explaining the data used in this paper. So data used in this paper were sourced, as I already said, in the municipality of Vršac in Banat area. So I already talked about the 13 years everyday calculating period, and it is important to say that soil nutritional content was derived also from 13 analyses performed by AgroZavod in Vršac, an agricultural expert, that is an agricultural expert provided for local farmers. And we have also asked for the data from Pioneer. Statistical methods were employed in order to multiply data instances. The data set contains the following features. So already mentioned, we obtained the data from the air temperature at 2 meters above the ground, and from the data given we obtained using as I already said we obtained the following: maximum daily temperature, minimum daily temperature, average temperature, dew point at 2 meters above the ground. Also, it is important to say that we had a sum of rainfall per day, which is important in the following. So when we label data, we first calculated evapotranspiration, then we multiplied evapotranspiration with the coefficient of the culture that we want to cultivate, and then to decide if on the corresponding day the plant needs to be watered or not, the value of evapotranspiration of culture that we want to cultivate with the sum of rainfall per day are compared, and then we see if the plant should be watered or not. So results are the following. We used 80% of the samples for training and 20% of validation. Since this is a two classification problem, we used linear discriminant analysis and k nearest neighbors classifiers. So k-nearest neighbors classifier is very useful in this case, since no training before making predictions is required. So new data can be seamlessly added and it would not affect the accuracy on the algorithm. We have in this table the results. As you can see, the results, the accuracy is very high, going up to 90%, and both of the classifiers are very tightly are very tight on the performance. So the results are quite reliable. Predictions are quite reliable. Also, we have here the graph saying if the culture should be watered or not, depending on the minimum and maximum daily temperature. As we see, black dots are saying that it should not be watered, and white ones say that it should be. Conclusion of this paper is that with using only minimum and maximum daily temperature and such easily obtained data, we can have a high accuracy for predictions and high reliability in pieces of advice that the user gets. So, and a very concrete piece of advice whether the plant should be watered or not. The same method can also be applied for different cultures, of course, not just these three that we used. It can be applied to any culture. Now, plans for future development, we are planning to have more measurements data of soil macronutrients. Also, those data will have help develop the possibility that system can foresee the input of a point of origin in terms of soil fertility and claim of the plant crop cultivation. The system will then advise the farmer on the amount of fertilizer that needs to be introduced into the soil in order to support such production. So besides watering, we will, by giving precise data, the user will have concrete advice for fertilizers as well. Also, considering the entire platform, this will have a high impact on developing a complete system of tools for managing businesses of the stakeholders, and also for calculating risks, trends, predictions, for better statistics, etc. And of course, overall, the decision making in the business will be much easier. So the question that we got is the following: can you discuss or describe the end consumer product which could be the result of the integrated prediction in the most common use case for farmers? As I already said, it is a part of a larger web platform, but also it will be a part of the smartphone application for the same web platform. So users will have their own accounts with their own data on them, and they could access their account and their information anytime, anywhere. They can so just provide the application very basic input of their goals and the basic information, I mean the basic data that the application needs for in order to make the prediction, and they will have the prediction and the advice. So as I already said, it is a part of a larger application, but everything is personalized, and it is a part of a network, so to say, for general digitalization of agriculture. Thank you for your patience and for your attention.